Hello friends, today also we are going to start with a famous quote of mathematics. It says, to understand the nature we need to study the language in which it is written, and the language it is written in is mathematics. So today we are presenting a game which I call the Seesaw Game, which the students had played in their childhood days, and the main topic is to make the students understand about the mean. So the main objectives of this program will be to make the students learn the concept of mean and to make them compare the value from formula and by the seesaw game. So things the students should know beforehand will be the simple addition and division and some simple skill of balancing the seesaw, so which they have already experienced by playing the seesaw game by themselves. So let's get started. So first we'll talk about the materials needed. First we need a long bar with a fulcrum in it. So this will be the fulcrum or the pivot point. I prefer using this metal bar so that it can attract the magnets. We can easily put the small circular magnets in it. So we need these small circular magnets so that they will be sticking on the bar by itself, and the two magnets can attract each other. So we don't need any other equipments to hold these magnets on the bar. And you can mark the metal bar with scale markings like I have done here. Like this is 5 cm distance, 10, 15 and 20 centimeter distance on either sides. So the question is, I have put these 4 magnetic circular bars over here. So the question is, on the other side also there are 4 magnets, but they are connected with each other, and you need to put these magnets in such a way that this will balance this lever. So at the starting point, the load created by the magnet is making the left hand side of the lever heavier, so the lever is not balanced. So you need to find a specific place for these 4 bars of magnets to put so that this lever will get balanced. So you can let the students play this game and do some heat and trials to find a specific position either in A or B or C or D. So they will start doing heat and trial to try to put the magnet in place. So they will go from here to here. Then after some heat and trials they will find a specific position where the lever will get balanced. So they will find that this will be the position where this lever will get balanced on both the sides. So the question arises, is there a way to find a position by using mathematics rather than just heat and trial? Let's take time to think. Yes, it is. So first let's write the distances in which the magnets are kept on this side. The first magnet is kept at a distance of 5 units from the center, so we are writing 5 here. The second magnet is kept at a distance of 10 cm, so we write 10. And the third magnet is also kept at a distance of 10 cm, so we write 10. And the fourth magnet is put at a distance of 15 cm from the center, so we write here 15. Then what we do is we add all these numbers to get 14. Then since there are 4 magnets, 1, 2, 3 and 4, so we divide the sum by 4 and get 10. As we can see on the right hand side, these pile of magnets are also at a distance of 10 cm from the center, and the weight of all these magnets is same as the weight of these 4 magnets. So there are 4 magnets on the left hand side and also there are 4 magnets on the right hand side. So what we can generalize is that the distance that these magnets should be kept to balance the lever is given by nothing but the mean of these values. So how can we find a mean? To find mean, we use the symbol x bar, which which is equal to summation x by n, and summation x is nothing but the sum of these values, or in this scenario the sum of distances the magnets are kept, and n is nothing but the number of circular magnets here. So to make it more comprehensive, let's use another example. So in this question also I have put a lot of magnets at different distances on the left hand side. So the challenge is to balance all these huge pile of magnets in one row and to find a specific position so that the lever will get balanced. So there are 10 magnets here in total, and there are also 10 magnets, but it is in the same row. So you can let the students do hit and trial and find a position so that the lever will get balanced. So after hit and trial, this will be the final position of the lever when it is in balanced position. So by using the same method that we used in the previous example, we now try to find the exact position by using mathematics. First, let's write the distances of these magnets on the left hand side. So these two magnets are at a distance of 5 cm from the center. So we write 5 and 5. These three magnets are at a distance of 10 cm. So we write 10, 10 and 10. And these four magnets are at a distance of 15 cm. And the last magnet is at a distance of 20 cm from the center. So we write here 20. Then we add all these numbers to get 120. And then we divide this value with the number of magnets, that is 10, to get the result to be 12, which is nothing but the mean of all these distances. But since when there are more magnets, it's very much tiresome to add all these numbers to get the result. So is there some easier process to do? And the answer is yes. We now introduce something called frequency. Frequency is nothing but the number of times a data has been repeated. For example, instead of writing 5 plus 5, we write that it is repeated for 2 times, and we multiply 5 and 2 to get 10. Also, since 10 is repeated 3 times, so we multiply 10 by 3 to get 30. Similarly, 15 is repeated 4 times, so instead of adding 15 4 times, we multiply 15 with 4, and so on. So by using the first method, we get the sum to be 120, and by this method also, when we add all these values, which is represented by summation fx, to get the same number as 120. And on this side also, if we add all the frequencies, then we will get the total number of magnets in it, which is 10. So it represents the total number of circular magnets here. So by doing summation fx by summation f, then we get the value to be 12, which is the same as we got from the previous method. So if we don't divide the data into their frequency, we can easily get the mean by using this formula, which says just adding the data divided by the total number of data. But the same formula can be represented by this equation if it is represented by some repetitions of frequency. So the formula gets transformed into summation fx by summation f. But by using these two methods, we actually get the same result. So looking at the seesaw also, we actually get the result to be 12, and as we can measure the distance from here to here is actually 10 cm, and I have divided these segments into 5 equal parts. So this is 10, this is 11, and this is 12. So it is actually in the right position. So by using the same concept of mean, the same principle is actually used in science also, as load times load distance equals to effort times effort distance. So you can also give the students a challenge to solve this problem by using signs also. And the development of the same principle is used in engineering to design the beams and columns for the house and buildings, and this is actually called the principle of moment. So in this case, it can be said that the sum of clockwise moments is equal to the sum of anti-clockwise moments in the case of lever. So thanks for watching and keep inspiring students.